Cast is now starting. All attendees are in listen-only mode.
Welcome, everybody. The Southern Alliance for Clean Energy is pleased to host the Southeast Coastal Climate Network's webinar series. On behalf of SACE and the Southeast Coastal Climate Network, I'd like to thank you for being with us today. It is your interest and support that make our work possible. My name is Erin Cameron, and I am the SACE Development and Outreach Coordinator, and I will be the acting facilitator for today's webinar, How Will Climate Affect Our Health in the Southeast? We will be recording today's webinar, so all of your lines will remain muted throughout the presentation to ensure recording quality. But we encourage you to please chat in your questions throughout the presentation using the question option on your control panel. We will then answer the questions at the very end of the presentation. The recording of today's webinar will be available on the webinar archive page of the SACE website, cleanenergy.org, and you will receive a follow-up message with a link to that page following the webinar today. So I'd now like to turn the presentation over to Chris Carnevale, SACE Coastal Climate and Energy Coordinator and Manager of the Southeast Coastal Climate Network. Chris?
Hello, everyone, and thank you for attending the webinar today. As Erin said, my name is Chris Carnevale, and I'm the manager of the Southeast Coastal Climate Network. The Southeast Coastal Climate Network is a coalition of individuals and organizations spanning the coastal Southeast who are working on coastal responses to climate change. We have members as far north as Maryland and as far west as Louisiana. The purpose of the network is to bring voices together, to trade information, and to synergize our efforts. The Southeast Coastal Climate Network is hosted under the Southern Alliance for Clean Energy. Our largest tool is our group site website, which is an online platform that enables members to send group emails, post discussion topics or relevant news to discussion boards, and use a shared group calendar. If you're interested in joining the network and using these tools, please just visit the web address on the screen now, seccn.groupsite.com, and click Join this group now. For those of you on this webinar who are already members, I want to encourage you to use these tools to help get your message out. The purpose of the group is to encourage communication and collaboration, and you have a receptive group of people at your fingertips. So please don't be shy and do use these web tools. Another great tool we have is our webinar series, of which today's webinar is a part. Today we're joined by Dr. George Luber for a presentation on health impacts of climate change in the U.S. and the Southeast. Dr. George Luber is an epidemiologist and the Associate Director for Climate Change in the Division of Environmental Hazards and Health Effects at the National Center for Environmental Health, Centers for Disease Control and Prevention. Since receiving his PhD in medical anthropology from the University of Georgia and joining CDC in 2002, Dr. Luber has served as an Epidemic Intelligence Service Officer and Staff Epidemiologist at the National Center for Environmental Health. His research interests in environmental health are broad and include the health impacts of environmental change and biodiversity loss, harmful algal blooms, and the health effects of climate change. Most recently, his work has focused on the epidemiology and prevention of heat-related illness and death, the application of remote sensing techniques to modeling vulnerability to heat stress in urban environments, and climate change adaptation planning. In addition to managing the climate change program at CDC, Dr. Luber is a co-chair of the Climate Change and Human Health Interagency Work Group at the U.S. Global Change Research Program, a convening lead author for the U.S. National Climate Assessment, a member of the American Anthropological Association's Presidential Task Force on Climate Change, and a lead author for the Intergovernmental Panel on Climate Change, its assessment report. So with that, I will turn it over to Dr. Luber.
Thanks, Chris, and thanks both to Chris and Erin for organizing this and for giving me this opportunity to address this group. I'm really appreciative of that. And I hope you will learn a little bit about climate change that you had not known before, and that is what the impacts are for human systems, especially health. And my talk today is going to summarize a broad range of information on the health consequences of climate change, but I'm going to focus it towards the end on impacts in the southeastern United States. And as a launching off point, we are in a period of time getting ready to see the Intergovernmental Panel on Climate Change. That's the image you're looking at now is the fourth assessment report issued by the IPCC, and this was a landmark report in a number of ways, and it really solidified our understanding of changes in the Earth's climate system and attributions to human activities. And I want to kind of summarize where we're at, because we're on the brink of the 5th assessment report, which will be released in 3 stages. The first stage on the physical science basis will be released towards the end of this month. And the next release, which will be what these climate changes mean for important sectors, including health, will be released in March of 2014. Now, I've been a part of this process for the last couple of years, been living it and breathing it, and I'm really glad that it's over. But we're living in a time where our evolution of knowledge on this topic is rapidly changing and enhanced. And when I say life in a post-AR4 world, what I'm talking about really is the evolution of our knowledge. I'm trying to get my thing to advance. There it is. And a fundamental shift in the types of questions that we're asking with regards to climate science. So before the publication of this last report, Climate Change 2007, which, if you'll recall, also won the Nobel Prize for their work. But the questions they were tackling then were primarily aimed at identifying the certainty in the changes that we're observing in the Earth's climate system. So, is global warming occurring? Whether or not those climate signals were related to human activities. Focus on identifying the particular climate drivers that are responsible for this warming, whether it's anthropogenic greenhouse gas emissions, whether it's land use change, whether the combination of natural drivers such as volcanic and solar radiation also have a role in it, etc. And those questions were largely answered in the 4th assessment report. Yes, there is a strong signal that climate change is occurring, that mirror patterns in emissions and land use changes, and our understanding of the relative contribution of various climate drivers was clarified as well. And really, in the heels of that came an enhanced interest in sectors, including health, in engaging climate change. For the first time, many groups that are non-climate scientists felt assured that they could engage this topic with some certainty that this was a credible threat to their sector, including health. And this report reflects the genesis of our program here at CDC. So following this report, we enter into a period where we're addressing a fundamentally different set of questions. And most important is, how quickly and how much climate change are we going to incur? We understand that there's nonlinear feedbacks, mechanisms, positive and negative, as well as nonlinear changes in the climate system, that we have to get a better understanding of how quickly we're going to have to prepare ourselves for this. What can we do about this? How can we mitigate greenhouse gas emissions looking forward, given that we're already seeing some of the impacts? But most importantly, brings us to today is what are the ways in which humans and natural systems can adapt to these changes, given the realization that we are already committed to more warming over the coming decades, regardless of our choice on emissions from here on out. If we were to stop emissions at 0 today, we would still incur some warming because of the persistence of these greenhouse gases in the environment and the delays in the climate system. So what the IPCC stated was that, yes, our observation of the climate record shows that warming is unequivocal, that physical and biological systems on all parts of the planet, not just the polar regions, are being affected by climate change, are already affected. And again, most importantly, we are already committed to more warming. Our choices about emissions now really affect the longer term and more. So what are we talking about? One of the take-home messages that I want to bring to you today is that climate change acts on human and natural systems primarily through changes in the distribution and magnitude of weather events, but it also has impacts independent of weather and independent of climate. And fundamentally, when we talk about climate change or global warming or global climate disruption, which is the White House's Office of Science and Technology Policy's preferred term for climate change, we're really talking fundamentally about changes in the composition of the atmosphere, the atmospheric chemistry. And as this chart shows, we have seen over the past 500,000 years temperature co-vary with other greenhouse gases such as methane and CO2, but within certain norms. What we're witnessing now is a marked deviation from anything we've seen in the past 500,000 years or longer, and all occurring over a very short period of time over the last 200 years. So it's clearly at the genesis of this is atmospheric chemistry, and we're seeing this reflected in global surface temperature. This is a temperature anomaly over the past 150 years, and you see that the really warming started occurring after 1980 is when we start seeing changes, and following the warming over land and air warming, we see increases in ocean heat content and a bit of a lag, much as you would expect from large bodies of water that take time to heat up. But we're seeing independent evidence of the air temperature impacts on ocean heat content, as well as other observations that lead us to believe that the oceans are absorbing more heat. Now, this is a chart showing sea level rise over the past 120, 130 years, and if you look at the average rate of sea level rise, it's about 1.8 millimeters a year. Not terribly startling or shocking, but disaggregate this sea level rise into shorter time periods, and we see that the trends are indicating an increasing in warming, currently up over 3 millimeters a year. That this warming, the rate of warming, is increasing much as we see the ocean heat content rising, and that is because sea levels are rising not because of greater inputs from terrestrial water, either glaciers or land ice sheets, but rather the thermal expansion of the oceans is resulting in this increase in sea level rise. Additionally, we're seeing changes to ocean heat content indirectly through Arctic sea ice extent. Both the winter maximum and the summer minimum are decreasing at a startling rate. And if you recall, 2007, we saw images like this, satellite images, where we saw a record low sea ice extent. This record in 2007 has since been broken in 2012. I don't have an image to show you. This is the fanciest one I've got. But 2012 broke this previous summer minimum record, and I believe it was just about a year ago today that record was broken, and waiting to hear whether or not 2013 turns into another record year as well. So indicators of a warming world are multiple, and not just related to temperature rise over land, but also, as I mentioned, ocean sea content, sea surface temperature, which we'll come back to in a couple of slides, sea level rise, but increase in water vapor as well as the decrease in the spatial extent of the cryosphere, or the ice on land on our planet. So what does the IPCC say? This is the fourth assessment report, the 2007 report, that stated that we're very likely to see the heat waves will become more intense and more frequent. Also, heavy rainfall events. This is rainfall above the 99th percentile for a location will become more frequent. That the nature of rainfall is changing from an increase in short, heavy rainfalls versus longer duration, gentle rainfall. We're also expecting to see more intense tropical cyclones or hurricanes with larger peak wind speeds and more heavy rainfall associated with that. Not necessarily more hurricanes, but certainly more of the hurricanes that we care about, the Category 4 and 5. Also expect to see an increase in the areas affected by drought and the impacts of sea level rise associated with storms. Important to note that our observation of warming indicates that warming varies significantly by region. We see more warming in the northern latitudes versus the southern latitudes, but other areas of the country, such as the U.S. Southwest, has shown a more intense warming trend than other areas. And if you look at the southeast over this period of time, 110 years, you see a slight cooling trend, actually, potentially related to the reforestation of the south. There's been a number of hypotheses as to why this is shown, but if you look at a shorter time period from 1970 on, you will see a warming trend in the southeast. But it's not just a warming trend, a switch in means, but a shift in the probability distribution of weather events. And what I mean by that is that if we take the expected temperature distribution and shift it to the hot side, to the right, we expect to get not only more hot weather, but also the tails of the distribution will expand as well. Now this graph is also showing not just a change in the mean, but a change in the amplitude of the distribution, which indicates a change in variance, so that the amount of the shoulder type events of hot weather or mildly hot weather will also increase as well, as will the tails of the distribution in their frequency. And this is very important for public health because it is these extreme events that largely manifest as life having health consequences. And some of these events, and many of these events actually, will be beyond anything we've ever seen. Now this is an image on the left of the European heat wave of 2003, which was a larger heat wave than they had ever experienced in Western Europe. And the impact of that is, the severity of that storm is evidenced in the mortality that was witnessed as a result of the storm. Now the chart on the table on the right shows the confirmed, this is mortality that was identified in death certificates as related to exposure to excessive natural heat or hyperthermia, indicating about 30,000 deaths were attributed to this heat wave. That's one way of looking at heat-related death, because we know that during heat waves a large number of health outcomes, from cardiovascular to respiratory disease, are impacted. And a much more accurate way of looking at heat-related mortality is to look at the excess mortality that was experienced for a location and a period of time over the expected mortality that you would normally see. And the excess mortality for this event in Western Europe was closer to 70,000 excess deaths versus the 30,000 as identified in the mortality. So clearly, these events can come with significant magnitude enough to incur a great risk to life. 70,000 excess deaths is nothing to be complacent about. But the other take-home message that I want to bring to you today, I've got a couple, I think, is that climate change doesn't act in a vacuum. That climate change is one of multiple stressors that will compromise our ability to withstand these changes or be able to prevent harm and death from these events. And the two other drivers of risk that are working with climate change or co-evolving with climate change are an increase in the proportion of vulnerable populations in our country and globally, as well as an intensification of climate-related exposures via the urban form. So I state that cities and climate are co-evolving in a manner that will place more populations in risks. And we're noticing trends in two things. I said vulnerable populations, and many of the risk factors for health outcomes from extreme weather events, including heat and storms, as well as many of the threats microbiologically to infectious disease, are represented by the advanced, those people with advanced age, elderly groups, elderly populations. And if we look at trends in population or demographics over the next 50 years, projected trends, we see that we're expecting a sharp increase in the proportion of population over age 65. That instead of having a population pyramid anymore, we get a population block with a nice little ledge on top, which indicates an increase in the proportion of populations that are vulnerable to these types of events, either through their diminished thermoregulatory capacity, their high prevalence of other comorbidities or chronic diseases, cardiovascular, respiratory disease, and also difficulty in transportation to remove oneself from harm. This isn't just a United States phenomenon, but we're expecting globally the proportion of population over 60 to double by 2050. Concurrent with this doubling of aging population, we have another significant demographic shift globally and historically that demonstrates that for the first time in human history, the proportion of population living in urban areas has exceeded 50%. So we are now, for the first time in human history, an urban species, living in an environment that has a high amount of engineered infrastructure that in many cases protects us from the elements, but in some cases it serves to intensify the exposures of weather and climate. Now, this image here is a nighttime satellite thermal image, a Landsat image, I'm sorry, an Aster image that shows urban Phoenix in the center of this, to the north of the center of this image. And now Phoenix is a great example of the urban heat island, but many cities in the southeast exhibit, especially Atlanta, where I live, exhibit a pronounced urban heat island effect. And what's important about the urban heat island effect is, yes, it does raise, as the image on the upper right shows, the temperature vis-a-vis the rural area during the day. What it does more importantly, in my opinion, is raise nighttime minimum temperatures. And we are seeing across the United States and globally in urban areas that nighttime heating is increasing, accelerating significantly. What this does is allows no cooling from extreme heat or even moderately hot days overnight, which has been shown in epidemiologic studies to be linked with greater chance of survival. So if you experience a 115-degree day in Phoenix, and at nighttime it cools down to 60 degrees or 58 degrees, your chance of survival is much greater than if you were exposed to a 105-degree daytime temperature and the nighttime temperature only dropped to 92. Well, Phoenix had its nighttime record low in 2009 of 99 degrees, indicating almost no cooling between the daytime high and nighttime low. This expands the period of exposure to extreme heat to individuals, and those suffering from or at risk of exposure to, or at risk of health effects from the exposure to extreme heat are put in further danger because they're not given any respite from the heat, given that if they don't have air conditioning. And even a few hours of access exposure to air conditioning has been shown to increase the survivability of extreme heat events. Another thing that it does is place greater demands on electricity generation during these peak hours of night when people are at home and are using air conditioning to cool their homes more, putting in greater vulnerability our energy, electricity grid and infrastructure, further enhancing the exposure of extreme heat. But the urban form also contributes to a number of exposures that are related to increase in temperature, and that is degradation of air quality. This image shows the relationship between temperature and maximum daily ozone concentration in Atlanta and New York City, and you can see from eyeballing this chart that the ozone concentrations do increase with maximum daily temperature as maximum daily temperature increases, indicating that as urban heat islands affect temperature, so will it affect the exposure to ozone as it raises daytime maximum daily temperature. Another impact of urban heat islands and urban form occurs through a phenomenon known as the CO2 dome around cities. Now, cities represent areas that have a high prevalence of mobile source emissions, meaning cars, and that those high prevalence of mobile source emissions raises the amount of CO2 in the environment locally vis-a-vis the rural area, much in the same way that temperature is elevated in urban areas. We have a locally high CO2 effect as a result of all these local emissions. And this CO2 effect stimulates plants in interesting ways. And this example is of ragweed, a common allergen in the southeast. And several studies have shown, this was one by a colleague of mine at USDA named Louis Ziska, where he planted 3 plots of ragweed plants across the transept in Baltimore, and looked at the response of these plants had to elevated elevated background CO2. So in the urban plot, he recorded higher average CO2 rates than the suburban and rural area, and that coupled with temperature effects in urban areas has been shown to increase the pollen production of those plants. In the urban plant, for example, urban plot produced about 12,000 pollen grains per cubic meter of air versus the rural plot, which produced significantly less, only 2,200 or 300 cubic grains. So the urban effect is having and is showing to have a pronounced effect on production of pollen plants. And we're seeing other impacts on pollen through longer growing seasons, as the first and last frost of the year are moving, indicating a longer growing season, as well as the background CO2 effects on plants. Other plants that are affected by CO2 fertilization include poison ivy, which uses this extra CO2 to produce more of its allergenic compound called urushiol. And so we've got super poison ivy to look forward to as CO2 rates exceed 400 parts per million globally. Other aspects of climate change, which act again on the urban form, but across the United States, is the impact that climate change has on heavy rainfall. And the reason why we get more rainfall is that a warmer atmosphere can hold more water, and this leads to a quickening in the turnover of the hydrologic cycle, so the rainfall comes down much harder and much quicker. Instead of a slow, gentle rain, we're getting a heavy downpours over shorter periods of time. And this is evidenced in the observational record over the last 110 years. This is a graph that will be released with the National Climate Assessment next spring. I'm giving you a sneak peek. And it's showing that the observed changes in very heavy rainfall over the United States have been increasing in the previous decades, and this holds true for many parts of the United States as well. The heavy rainfall has been shown to be associated with waterborne disease outbreaks in the United States. An analysis of 50 years of waterborne disease outbreak data showed that about two-thirds of those were preceded by two-thirds of waterborne disease outbreaks were preceded by rainfall above the 80th percentile for a region, and half of those outbreaks were preceded by rainfall above the 90th percentile. And if we look at the the largest waterborne disease outbreak in U.S. history in 1993, this too, we had an outbreak of Cryptosporidium, a protozoa, that sickened over 400,000 people, and this too was preceded by the heaviest rainfall in 50 years. And these aren't trivial events. They account for a significant amount in medical costs as well as lost productivity when you have about 400,000 people with GI illness in the city. It can have a significant impact. In many parts of the world, heavy rainfall, especially in urban areas, can lead to very intense and severe flooding, landslides, etc., especially as in urban areas that are engineered to deal with, or engineered to greater or lesser degree to deal with these heavy rainfall by transporting water off impervious surfaces and into rivers, which quickly become swollen. And if you look at the vulnerable populations to these types of flooding events, you only have to look at the squatter settlements around cities in developing countries to see, who decides to live in these low-lying areas are the folks that have the least resources to cope with these type of events. And in Mumbai in 2005, we saw a heavy rainfall event, granted 37 inches of rain over a 2-day period, led to over 1,000 deaths. On the other end of the hydrologic extremes, from flooding and heavy rainfall, we see other effects that impact health, and a general drying out of the U.S. Southwest and an increasing drier climates in the Southwest has led to an increase in forest fires and the emissions associated with those. So if we look since 1970, the wildfire season in the U.S. West has increased by over 2 months, 2.5 months, and the duration of fires has increased 5-fold as well. And this is not just an effect on natural systems and loss of life from injuries, but we see in many wildfire events an increase in non-accidental mortality of varying intensities as a result of an increase in what we call PM10, which is large particulates or large size particles, air pollutants. We have generally 2 types, PM10, which is the wildfire-associated large particles, and then PM2.5, which is associated with combustion of fossil fuels and other sources that are actually more hazardous to people. But in a number of cases, we see a general rise across the board in non-accidental mortality associated with wildfires. In the Australian brush fires, for example, we saw overall rise in mortality of 5% and a rise across the board for hospital admissions. in the U.S. Southeast, we saw a significant impact in a wide variety of health outcomes: COPD, asthma, pneumonia, and heart failure as a result of exposure to the peat bog fires in North Carolina. Associated with drought and dry conditions is degraded air quality from forest fires, but also degraded air quality from dust storms, especially in the Southwest. This is a storm that hit Phoenix in July of last year. These types of storms, the dust storms, are called haboobs, and they result in an increased likelihood of injuries from motor vehicle accidents. Can you imagine a wall of dust like that coming at you while you're driving? I can imagine it to be very difficult to drive in, but also an increased risk of asthma-related hospitalizations as a consequence of degraded outdoor and indoor air quality. But in addition to the air quality effects, there's potential for the dispersal of certain pathogens. And in the desert Southwest, they have a recurrent issue and a recently intensified issue with a type of fungal disease, a mycotic disease, called coccidioides mycosis, otherwise known as valley fever. And it's hit epidemic levels this year and last largely as a consequence of the drought in California and Arizona. Now, this is a fungal pathogen that is endemic to the area. It lives in the soil, and it thrives during wet periods and is dispersed through dispersal during the dry season when it becomes airborne. And the increased intensity and duration of droughts, especially in the Southwest, is proposed or hypothesized to be behind the current increase, a dramatic increase in numbers of cases of this valley fever. But there's a global impact as well, as we see dust storms in Africa, sub-Saharan Africa, and the Sahel. As the Sahara and much of northern Africa is drying out, and the increased desertification of the Sahel, we see larger and larger dust storms. And as these dust storms leave the African continent, they're transported across the Atlantic Basin and deposited in the U.S. Southeast. And the front line of this is the West Indies countries, and many of them are reporting that during these dust storms that they have a marked increase in asthma-related complaints, as well as biologists have noted the deposition of foreign pathogens. Aspergillus is another fungus that is associated with foodborne illness, Aspergillus flavus and Aspergillus, I forgot the name of the other one, which infects corn. This is one that has been identified in coral reefs, a bit of a different species. But nonetheless, the global transport of particles and pathogens has been evidenced as a result of increased dry areas around the world. Now, in the Southeast, we're very familiar with storms and keep an eye on them. And I'm from Florida, and frankly, only care about the large-scale storms. We tend not to get too excited about the Category 1s or 2s, but when it gets to 3, 4, and 5, that's when we start paying attention. And those are the types of storms that have been shown provisionally to be increasing with climate change. Now, our window of observation for hurricanes or tropical cyclones is rather short, starting really with the advent of the satellite era and our ability to monitor storms in the open ocean. Prior to that, if a storm wasn't encountered by a boat or didn't hit land, there's a good chance that we wouldn't know it ever happened. So our real reliable observation window is rather short, but indicating an increase in Category 4 and 5 hurricanes. Other impacts related to sea level increase in sea surface temperature and climate change, as well as increased runoff from heavy rainfall events that are seeing an increase across the Southeast, is an increase in the frequency of harmful algal blooms, which for many folks are really not a health threat, but a nuisance to tourism, nuisance and an economic impact to tourism and fishing. Well, more current research has shown that the classic Florida red tide, the Carina brevis blooms, do have health effects, especially for those with respiratory conditions and those exposed to the tide occupationally, such as lifeguards, who have shown decreased lung function during these events because of exposure to a toxin that's produced by the harmful algae. This is a toxin, the image on the lower left is a Carina brevis bloom, and the toxin is known as brevetoxin. But we're also seeing impacts that have potential health impacts in freshwater sources. The image on the right shows a distribution of a formerly tropical cyanobacterial bloom, or blue-green algae, called Cylindrospermopsis, which is now found across many freshwater lakes in Florida, as indicated by the black dots. A changing geographic distribution of this formerly tropical pathogen. And also of interest to the southeast is the geographic spread northward of a formerly tropical harmful algal bloom associated with a marine toxin called Ciguatera fish poisoning. This is a type of fish poisoning that one gets by eating fish that have acquired this toxin by eating algae off the reef, and the large fish eat the smaller fish, and it bioaccumulates up. But we now have suitable sea surface temperatures, and as a function of the 4,000 or more oil rigs found in the northern Gulf of Mexico, that's the image on the lower right, we now have suitable habitat for this, and we're now seeing an increase in cases of Ciguatera that are caught, got from the Ciguatera that are acquired from fish caught in the northern Gulf of Mexico and in the southern Atlantic. Certainly, from a news media standpoint, vector-borne diseases or malaria gets most of the attention. Now, there's no evidence that malaria will become reestablished in the U.S. Southeast. It has been formerly endemic in the Southeast, and that was actually the original mission of CDC, was to eradicate malaria in the Southeast for the war effort. But because we have a well-developed public health and vector control infrastructure and mosquito control infrastructure, we don't expect malaria to become reestablished. But globally, there is a concern that because of climate change, vector distributions, these are insects, fleas, ticks, etc., will increase poleward in latitude and up mountains in altitude as well. And we're seeing evidence of a shifting geography of vector-borne disease through our analysis of Lyme disease. The image on the right is showing the range of suitable habitat for the tick that is the vector for Lyme, Ixodes scapularis. And if we look at the combination of ecological, social, and climate factors, given that each one have a significant role to play in the distribution of whether or not somebody gets Lyme disease, we see hypotheses such as the modeling exercise on the right, that as I animate it, show a westward and northward expansion of suitable habitat for Lyme into the latter part of the century. And we're starting to get some indication that climate change might be altering the distribution of Lyme cases through this image, which is CDC surveillance data, showing, just as the image I've showed you before, a spread northward and westward in the numbers of cases of Lyme. And actually Canada is dealing with an increased incidence of Lyme as well as a result of changing climate. Now, just to reiterate, there are numerous factors that are responsible in disease emergence and disease in changing geography of disease. Climate and weather is one of them, but to a lesser or more important degree, depending on the case, an important one as well. We have to understand that there are also genetic and biological factors such as microbial adaptation to changing environments, as well as ecological and certainly social political factors as well. One thing that is a persistent threat to climate change. Now, just to summarize, I've talked about some of the direct effects of climate change on health, extreme weather events, degraded air quality, and I've mentioned briefly some of the impacts of climate change on health through altered ecosystems, harmful algal blooms, Ciguatera fish poisoning, for example, as well as vector-borne diseases. And those are the effects that we call indirect effects, that as we alter the ecology of an area, we alter the potential for diseases to thrive or not thrive in an area. But there are also systemic or downstream effects of climate change that weigh on the health of communities as well. And mental health is certainly principal among one of them. And we have a good understanding of the effect on mental health of disasters, but looking at prevalence of PTSD, in communities that have suffered from disasters. And it could turn out that the mental health consequences of disasters are the most significant in a disease burden sense of all the impacts of extreme weather events. But there are other impacts of climate change on mental health that are not related to extreme weather or suffering from extreme weather, and that is the anticipatory effect. Living in a world that has apocalyptic visions of the future with a significantly changed climate. And what's most important is that there's some evidence that this is weighing in on children who, in many regards, we are counting on as the generation to take up the charge for action on climate change. And it's important that as we frame our discussions about climate change and impact, to provide actionable advice and solutions rather than descending in a world of paralysis through the anticipated health effects, anticipated impacts of climate change on society, much in the same way that the thoughts of nuclear annihilation during the Cold War had measurable mental health effects on children. But in addition to the impacts on anticipating a changed world, also the impact that these degraded environments have on mental health through the loss of cultural resources. Now, this village of Shishmaref in Alaska is a classic, well-cited example of a community that's literally crumbling in the face of climate change with coastal erosion in Alaska as a result of diminished winter ice pack. And many folks might wonder, why don't we just move this town, which is living on a vulnerable spit of land in the Bering Sea or the Chukchi Sea, into some inland areas? And the answer is that they are there because their ancestors are there. That these people have been living on this piece of property for many thousands of years, and they're there because their ancestors tied them to this place. And the loss of ancient graves pulled to sea has a dramatic toll on the cultural identity, the identity of place, and loss of significant cultural resources that have very profound impacts on communities. So how about the southeastern United States? I've got, I think, about 2 minutes to go through this. And I'm just going to highlight some findings from the draft U.S. National Climate Assessment, which, like the IPCC process, is conducted periodically and is under review right now, but draft public drafts have been released. And I'll highlight some of the impacts that we expect in the Southeast from that. And that is, by 2100, the Southeast is expected to have the highest increase in heat index, that's temperature and humidity, of any region in the country. And extreme heat causes more deaths annual than all other extreme weather events combined. It's a silent killer, but nonetheless a significant one as well. And this affects a wide variety of individuals, including those with cardiovascular, respiratory, and mental health cerebral conditions as well. Ground level ozone is projected to increase in the 19 largest urban areas of the Southeast, leading to an increase in premature deaths. We mentioned the mechanism by which this happens. And food and waterborne disease are going to be challenges as well, as many of these pathogens, such as Salmonella, Campylobacter, and others, are more common during higher temperatures. And there's some estimates that Salmonella and Campylobacter will thrive in a warming climate. Examples of saltwater intrusion are abundant, including the city of Hallandale Beach, which has abandoned 6 of their 8 drinking water wells as a result of saltwater inundation to them. Corn yields in Georgia could decline by 15% through the next 10 years or 7-8 years, and 20% through 2020 across the Southeast, as well as a decline in livestock as the thermal stress can impact livestock as well. And this could lead to increasing prices and consumption of lower quality, high calorie foods, as it has been shown in many food-stressed environments. Potential for an increase in the suitable habitat for many mosquitoes, including the Aedes albopictus, that is one of the vectors for dengue fever. And there's some indication that dengue fever is now endemic in southern parts of Florida and Key West. And there's some concern that rising temperatures will expand the suitable habitat for that. Now, whether or not that will result in a changing geography for dengue because of vector control efforts is still unclear, but certainly suitable habitat for new infections or new challenges such as chikungunya fever will have more potential. And I mentioned harmful algal blooms will become a persistent threat as the frequency and range of these are increasing, including Vibrio bacteria and coastal shellfish will become a heightened threat. We saw numerous challenges to healthcare as a result of extreme storms and coastal inundation, breakdown of critical systems during these storms. And as the Southeast has a high proportion of populated coastal areas, this is of particular concern to the Southeast, as well as migration and displacement, loss of important elements of the workforce, et cetera, following these storms. It will dramatically alter, as it has, the demographics of particular areas, as well as changes to coastal ecosystems, a loss of coastal resources. And again, mental health issues. Clearly, a third of Hurricane Katrina returning residents had some indication of the need for mental health assistance, and our provision of that mental health services is going to be challenged in face of increasing need for it through the impact of these storms on communities. So, as I summarized briefly, the potential health effects of climate change are numerous, from direct effects of heat to the indirect effects of changing disease ecology, and to the downstream effects of impacts on critical systems such as water, food supply, and the potential for conflict of a scarce resource and migration that might associate that. Many of these threats are not new. Most actually are not new, but they will be intensified and amplified in certain areas. Some existing health threats, such as cold-related disease, will diminish in light of a warming climate, but the overall impact will be of a challenge to public health in general. And I'm going to end there. I was going to talk briefly about our program in climate change and health at CDC, which the take-home message is that we have a wide variety of activities providing decision support to those working on climate adaptation plans, and we fund a number of states around the country on climate adaptation planning called our Climate Ready States and Cities Initiative, and including 2 states, North Carolina and Florida, in the Southeast, just to highlight the activities we have through our BRACE framework, which is the activities that our grantees are performing in a stepwise approach, evidence-based approach, to arrive at adaptation plans using available scientific evidence and disease modeling activities. So in order to leave time for questions, I just want to conclude with the point that following the 2007 report, climate change, I believe now, is a mainstream issue, at least being discussed in the mainstream, but it needs to be framed as a human welfare and public health issue, and not just an issue that affects polar bears and plants, but people should be at the center of this equation. And the opportunity costs of not taking action now are far too high to ignore. And with that, I'll end with my contact information and some time for questions.
Great. Thank you, George. That was a wonderful presentation. We have a few questions here. Let's start with this one, and there's 2 questions here. Are there urban areas or states who are leading the way in adaptation to public health impacts of climate change? And then kind of the second part, this is a separate question, but it fits in nicely. How does a state initiate the Climate Ready State program?
Okay. Yeah, there are areas throughout the country in the United States and globally that are leading the way on a number of fronts, especially with mitigation in dealing with greenhouse gas emissions, but also, and that would be cities like New York City, Chicago, which are putting in policies that are tackling climate change or greenhouse gas emissions through retrofitting buildings with more efficient heating and cooling, white roofs on buildings and green roofs on buildings. What we don't do well is tying those benefits, those climate emission benefits, greenhouse gas reductions, to potential health co-benefits. So for example, if we understand that we'll have a benefit to greenhouse gas emissions if we cool cities by virtue of not using as much electricity, we also have co-benefits for health in that we have a reduction in exposures that are climate sensitive, things like urban heat islands for air quality and heat exposure, but also the idea that green roofs help in heavy precipitation by capturing some of the water that would otherwise fall on impervious surfaces and helping to store it and release it over longer periods of time through green roofs and other strategies. And I'm sure this audience is well familiar with multiple other climate mitigation strategies. The real goal is the real challenge, I think, and a goal of our efforts is to identify the health co-benefits of those strategies to not only help promote those strategies as good strategies, but also to benefit public health and human welfare at the same time, giving it a double win with carbon reduction emissions and tackling a human health or human welfare issue. Our program, our Climate Ready States and Cities Initiative, currently funds 18 health departments, and we would like to see that increase. But our program is funded through a competitive process of soliciting proposals from state and municipal and territorial health departments, and then going through a competitive review process. Our current grant funding opportunity is closed. We announced it this spring, closed over the summer, and made awards to 10 health departments to work on our climate adaptation planning, Florida amongst them. And we won't, for another 3 years, be announcing another competition because we have fully committed through a 3- and a 4-year cycle the funding that we have available now. So without any increase in our funding levels, we are committed to supporting those groups over the next 3 years, and at the conclusion of that, to announcing another funding opportunity.
Great. Thank you. Here's a comment. Thank you for your perspectives on mental health and anticipatory effects of global warming. As a parent of young children, I'm particularly interested in this public health impact, given there's so little discussion around it in general. So thank you for covering that component. Here's the next question. Does the urban heat island effect level off at some point, or does it decrease if we have too much CO2? Maybe we could say or other.
That's a very good question, it's not that easy to answer. The urban heat island effect is not a kind of a monolithic type phenomenon. There is a tremendous amount of variation within the urban area, within the urban area, about how much hotter it's going to get in a particular neighborhood, and this is really visible at a small scale, small spatial scale. At a neighborhood scale, for example, some neighborhoods that have a lot of trees, a lot of green space, a lot of the effect of evapotranspiration or the effect of plant respiration on microclimates is pretty significant, in that one area might be only about 2 degrees warmer than a neighboring area because it has low green space. But what we see is that during extremely hot periods, those differences become much more profound. There was an excellent study done in Phoenix characterizing neighborhood microclimates around the Phoenix area, and they demonstrated that areas that have a lot of green space, a low prevalence of impervious surfaces or dark colored surfaces such as black parking lots or dark roofs, tend to be cooler than the areas that don't, the areas that have a lot of heat island driving phenomenon like impervious surfaces will be a bit warmer than other surrounding neighborhoods that have a lot of green space. But during a spike in temperature, the differences are magnified dramatically. So you'll get maybe a 2 degrees worth or 3 degrees worth of difference between a hot and a cold neighborhood in a regular part of the summer, say an 85, 90-degree day, but in a heat wave, those differences are amplified where you get maybe a 15-degree difference, indicating that the areas with a high amount of green space stay cooler during extreme heat, and the other areas fluctuate much more dramatically. That's not necessarily related to CO2. It's related to exposure to solar radiation and temperature. And so that gives us a clue, though, in saying, if we can characterize which neighborhoods are hottest, we can also characterize which neighborhoods are more vulnerable to extreme heat, such as with metrics such as a proportion of elderly in a census block group or other demographic factors. But it also gives us an insight into which parts of cities we should tackle first when trying to implement things like urban canopy initiatives, urban greening. If we were to tackle those highly vulnerable neighborhoods first, ones that have the highest heat island signal, we would have the greatest effect on reducing health outcomes and air quality concerns as well. So understanding the variation within a city is as important as characterizing the cumulative effect of the urban heat island.
Great. Let's do one more question and then wrap it up. So we have some some questions about what people can do to make an effect on the health impacts of climate change in their community. Can you recommend what are some actionable items that people on this webinar can bring home and enact?
Well, I might make some suggestions for those that are involved in climate change policy, and that is to look for synergies in your efforts to engage climate policies with sectors that are concerned with human health and welfare. It's been often shown that core topics that people care about are their health and their pocketbooks. And efforts to mitigate climate change are often seen as working against people's welfare in the sense of their economic and health interests. If we reframe that dialogue by including health metrics, health outcomes, positive health benefits, as well as economic benefits of climate action, the proportion of people that might be interested in those initiatives would increase. And tying specifically climate action strategies to health benefits again gives added support at a local level through reduced healthcare costs. Also is a fantastic communication and marketing tool as well. So I would encourage those of you who sit on climate action plans or discussing climate initiatives to consider including somebody from the public health sector in your discussions. It's one of our goals as a program to build enough capacity in the public health sector so that they feel comfortable sitting in discussions about climate change adaptation or mitigation and have enough expertise to provide contributions. And once we get, and in Florida, is one example, has great expertise in this topic. And I would just encourage you to reach out to health departments to include them in these discussions. They're typically not considered as participants in these groups, but would offer something, I think, of great benefit.
Great, great, wonderful. Excellent. Well, we have a couple more questions here that we didn't have time to get to. So for those of you who submitted questions that weren't answered, I apologize, and we will try to follow up with you via email to get your answers, to get your questions answered. Thanks a lot, George. This has been great, and yeah, we'll pass the floor over to Aaron to wrap us up here.
Well, thanks, everyone.
Yes, thanks, George. Thank you, Chris. And thanks, everyone else on the call for attending today's Southeast Coastal Climate Network webinar. SECCN is very excited to host this webinar series, and we would like to thank all of our members on this call and encourage those of you who are not members to please join us today. For more information, please check out our website, cleanenergy.org. And again, today's presentation will be available on the webinar archive page of our website. Thanks, everybody, and have a great day.